Okay, the next speaker, I'd like to introduce Michele Guidotti. Give him the microphone there. Michele is a graduate of the ETH Zurich and the MIT Sloan School of Management, an IoT expert with extensive experience in the lift industry. At Schindler, currently at Setters, and he's a senior product manager working on IoT business case. Welcome, Michele.
Thank you, Phil, for the introduction. Hi, everybody. So again, my name is Michele Guidotti, and I'm working currently for a sensor supplier located in Switzerland, CIDES. And yes, this is the remote control. Thank you a lot. So again, we are all turning and talking about IoT and the potential about IoT. I will spend a few words about it, more focus on sensors and what kind of data and unlocking the power of the data within the sensors. How does it work?
Going to sleep, maybe you need to turn on the side here. Just check. Oh, sorry, that one.
So IoT, the Internet of Things, is much more than a buzzword, actually. Just to give you a number, a figure, keep in mind that today connected IoT devices, the number of connected IoT devices is bigger than the number of mobile phones globally. So IoT, it's really already here, guys, and it's already a presence. And also in the elevator industry, this IoT journey, this digitalization, and you have heard from my predecessor, the guy talking about IoT, it's ongoing with different speed and different rate and different penetration, but the adoption of IoT, it's ongoing in the elevator industry. Maybe the front runner are the big players, but also other companies are catching up in this full digitalization. Data is the heart of any IoT product. That's really the key. And the topic is how to acquire that data, how to extract, how to unlock that data. Yeah, in today's lift system, there are already plenty of sensors installed for various functions. However, the full potentiality of those sensor and data is by far not yet exploited. So this is the issue, whether you have to install additional sensor to get data out, or you can better use the today's sensor already anyhow in an elevator system to control the system. That's the key topic. So various sensing devices built into modern lift, from simple like curtain to complex time of flight sensor, are already capable of collecting a large amount of data, which can be very useful. I really don't know how to manage it.
It's not working. Just push on the side here, this one.
At this side.
I think it goes to sleep. You have to push once here. And then
Okay, understood. Thank you. Thank you for the IT support. Now, okay. So as an example, an absolute positioning system combined with the new generation of powerful EN81 2050 compliant safety supervising unit can provide large amount of data. In this picture, you see, first of all, some a 6th-floor tower, and you see what kind of simple data actually you can be all familiar with, can be acquired for an absolute positioning system. You see, you of course have the position, you of course have the velocity of the elevator, you also have the trip profile, the actual trip profile for every single trip, thanks to this data. But additionally to that, and here just an example, this kind of sensor provide you not only that, but also the configuration of the lift. So how many floors, the distance between the floor, and so on. But farther than that, and these are very trivial examples, you can also extract statistical usage data like total trip counter, number of trips per floor, total travel distance, and so on. Now, the safety supervision unit monitors additional several data points related to the car position and the elevator status. And in this picture, you see a 3-floor lift representing the different car zone. I don't go into the detail, but now in the next slide, I will show to you a sort of simple dashboard So visualization, important about data is not only collecting the data, but making this data then available to the end user. So in this dashboard, again, is the same elevator. You can see all the data collected visually of this 3-floor elevator. And I go now through the list. Maybe for most of you guys, these are very clear data, but this is the kind of thing you can get out of the existing sensor. This is my message here. So around the car position, you can get leveling, releveling zone data. You can get final limit switch, whether they're on and off, or the inspection limit switches, or even the extended inspection limit switches. Around the door, you can know the door status, whether it's open or closed, but also the door contactor monitoring, whether it's breached or faulty. And about the safety, so safety chain, whether the safety chain is it's open or closed, the overspeed detection, the detection of UCM, so unintended car movement, and even the safety gear monitor status, whether it's on or off. And even other kind of information, like if the elevator is in inspection, if someone is in the pit doing an inspection, if a car door, if there is a car door, it's open, or if the door in the pit, it's open. So you get plenty of information that are very useful. Well, let's see if it works. It works. Thank you. Now, another example about door safety edge devices and the kind of data can be unlocked out of these devices. So I started saying that in 2019, North American Elevator Safety Code defined new requirement for means of detecting person or object between the door or approaching the elevator. So so-called 2D and 3D technical solution. A light curtain combined with a 3D TOF, time of flight sensor, and a controller can fulfill those code requirements. And they monitor actually this zone, this triangle around here can be monitored, and you know exactly what's going on around the door. Here it's just a visualization without going to the detail that what kind of data can be extracted from those sensors. So people or object classification, detection, using time of flight and image processing technology can be used. And so this is more about detecting what's going on in entering or leaving the elevator. But in addition to that, these 2D and 3D images of the door itself give a lot of diagnostic information about the door status and about what's going on with the door. Here, just now, it's just an example of a dashboard, just empirically done like that. It's just to show how of this data I just showed to you, visualized before in the previous slide, the kind of very trivial information that can be extracted, but very useful information that can be extracted from the system statistical usage data could be derived, including so number of people and object detected in front and between the doors. So you can have actually an information about the flow in and outside and out of the elevator. Of course, you have, again, also with this kind of sensor, door status, open, closed, the number of door cycles, the number of door reversing, and door opening and closing time. By the way, I think as mentioned by some colleagues of mine before, door, it's the primary callback generator in elevator system. So the more data we collect about the door, the better we can control and understand what's going on and what's eventually needed in an elevator system to be performed as a maintenance task. So yes, here, and partially already mentioned by the guy talking before me, I tried to list here some of the benefits for the Lift company of the IoT, this digitalization of this data, exploiting the data, and what can we do with the data. The challenges in today's competitively market is the inefficiency of the maintenance process, the lack of data transparency, and a wide variety of lift types, because an elevator can live longer than up to 40 years or so. So the guy in the field are confronted with any type of data, any type of elevator and any type of technology around it. IoT-enabled sensor solution provide an answer to those challenges, opening the way towards data-driven maintenance. And here I try to give you a few practical example of what are the advantages and benefits of this data-driven maintenance. So first of all, to adapt, depending, of course, on the local code, the interval. So still fulfilling the time-based prescription maintenance needed, but you can still adapt. Maybe you go 1 month later, 1 month before, depending on the country again, and the rule between the maintenance visit, depending on the actual status of the elevator. So you just not follow the time rule by itself. You also gather the data about the elevator and decide whether it is worth to go now or to postpone a bit the visit. Another big advantage is that you can go away from fixed maintenance checklist and activity that's checking everything, because some of the check are already done thanks to the data, so you don't have really to check it again. Or the other way around. Let's take again the door as an example. If the door is performing perfectly, why touching it? But I would rather say better not touching it. So you can take this decision about, that's why it's called data-driven, about what to do and what not to do. This is the power of this of the data. Then another thing, it's about, depending on this data you collect about the specific equipment, is you can then decide the right team, equipped with the right tool and the right spare parts for that activity. So that's also a key activity. So you will avoid several trips to the elevator because you already know, you collected the data, you know exactly what is needed to do on that elevator. Then, of course, thanks to the data collected, early detection of anomaly helps preventing breakdown and reduce the number of unplanned visits, as already mentioned. And thanks to this data, technician can find and eliminate the error much quickly, reducing significantly the downtime of an equipment. Easy to install in any type of elevator, IoT-enabled devices offer great advantages in modernization as well as new installation. Now, what about the advantages for the end user, which here I list as building owners and facility manager? And this, I think, was also already mentioned by someone who talked before me. The big difference, the crucial change that brings IoT is data transparency. Now, finally, end user can have this data transparency they never had about their equipment. So real-time data about the condition becomes the basis for informed decision and an important element of smart building ecosystems. For example, and I shortly addressed it before, people counting and traffic analysis can improve people flow management and increase the overall energy efficiency in a building. Of course, an end user also benefit from the enhancement in the maintenance efficiency per se, of course, because fewer breakdown and faster repair time can finally result in a reduced maintenance cost and increased elevator availability, which leads to a greater tenant and visitor satisfaction. Another important topic to address is that increasing passenger safety is the latest benefit of IoT-enabled sensor solution. For instance, an example could be an automatic notification of a blocked elevator with people trapped. So there is even not the need of the guy pressing the alarm. We can detect that and automatically trigger to the central, hey, someone is blocked, hey, this elevator is blocked and someone is blocked in this elevator. Conclusion, I come to a bit of a summary. So the IoT-enabled elevator market is estimated to be worth $2 billion in 2028. So there are several numbers here from analysts, but anyhow, it's a big business everybody's looking at. IoT solution offer Lift company competitive advantage in an increasingly connected and digitalized world and becoming an important factor in driving business value. access to the data, so data are the art, increase maintenance efficiency, and constitute a major added value for the customer. The message here is that many elements of modern lifts are already capable of collecting or potentially capable of collecting this valuable data. As an example, I presented includes an absolute positioning system, a safety supervisor system, time of flight sensor, and even simple light curtain can collect very sensible and valuable data. IoT technology, in combination with machine learning and autonomous decision-making technology, provide the key to unlocking the existing potential. Various types of IoT solutions for industrial use exists, but no standard yet it's available. So the convergence of these multiple technology, starting from the sensor, going to connectivity, which in a shaft elevator, it's still an issue, and several technology can be used for that. Increased powerful embedded system and machine learning are still ongoing. And with that, I'm at the end of my short presentation. If there is any question?
Okay, thank you, Michele.